So please welcome Rafael. He will talk about writing code you won't hate tomorrow.
Bonjour. That's about as much French as I can do without insulting all of you. Good, I got somewhat over the crowd. All right, cool. So I think he did such a good job explaining to us, talking a lot about the work we do in terms of delivering value, and I think that's really important for us as well. And I think there's a kind of second side to it. So I like how these two talks are going to complement each other, because I want to talk about another problem that we developers face on a day-to-day basis, and that is the problem of looking at the code we wrote yesterday. I mean, how many of you open up an old repository from someone else or some code you saw from someone else and react like this? Like, oh my God, did I really write that? Did I do that? Right? How many of you feel like that? How many of you are not being honest with yourselves? Cool. Or maybe it's not your code, it's someone else's code, and you're like, why? Why do we do this, right? That's why we hate legacy code. We look at this code and it's like, why did people make these decisions? Why is it fighting against me every time I try to do something? And then we have that urge of just simply needing to rewrite all of it, right? How many of you feel like this is your job, actually? Rewriting code, that's just what it is, right? And that's simple, because we as developers, we believe we can do better. We always believe we can do better than we did yesterday. We always believe we can do better than everyone else. That's fine. It's part of being creative, You believe you have a new approach. You believe you have a new way. Now, there's one other problem with that, and that's a saying that bounces around the internet constantly, which is that real developers ship stuff. That's great. Shipping stuff is really important. We learned all about delivering value, and I think if we don't deliver value, then what are we doing? Because at least in my world, clients don't pay unless you deliver. Does anyone get paid without delivering? Okay, good. I'm doing something right then. And at the end of the day, we have to balance that. How do we figure it out? Now, just delivering is not enough. Just delivering is not going to cut it. Let me tell you a little story about that. So, if we look at, this is the Tacoma Narrows Bridge in Seattle, in the US, and it was built around November of 1940. So they needed to get across the river, they built a bridge. The project was quick, the project was actually executed in really good time, and it was delivered. So they shipped it. They actually shipped it. All right, so imagine this is your website. You've just delivered your website, and that's great. People are getting across. However, just 4 months after that, the winds in the area picked up slightly. So imagine you're getting a little bit more of an influx of clients to your system. Now, more people are coming in. Your system is starting to react weird. You're looking at the logs. Something is off, and it keeps getting worse. Now, I'm an engineer. Imagine this is your website. So I'm pretty sure bridges should not be doing that. And I don't think you would want your website to do the same. Right? Imagine this is where your alerts start going off. And here everyone's getting PagerDuty pages, all the emails, you're getting all call in. It's probably not good. You probably don't want this, right? And that's the thing. This bridge lasted all of 4 months. 4 months. Can you imagine how long it took to build that bridge, the amount of effort that goes into that? And in 4 months, because you probably forgot the calculation about resonance, which is the case for this bridge, and that happens. Can you imagine putting the same effort into your website, and then a week later you're like, well, this was great, I'm going to rewrite it now. We can't keep doing that. So we need to find balance. And if that doesn't give you enough motivation to find the balance, there were no victims of that bridge, except for a dog. So, killing a dog doesn't sound like a good way to start, just saying. So how do we find that balance? How do we find a balance between delivering, keeping the quality up, and still, being able to keep code that you will not have to keep rewriting over and over? So I believe, and I've looked over much of these projects, I'm trying to figure out why is it? Why is it that we resist our old code so much? Why is it that we feel that code goes bad, right? Code is like perishable. If you leave lettuce out too long, it gets black and horrible and you don't want to eat it. And the same thing happens with code. If you just leave it there and you look at it again, it's like, oh, wow, this doesn't look good. Why is that? And if you go look at all these reasons, a big part of it is evolution. Everything around us evolves. The language we're using, the framework we're using, and you. All of these things evolve. You learn new things. I mean, to be fair, if you don't hate the code you did yesterday, you probably haven't learned anything new, and that's also bad for you, right? I actually feel good when I look at my old code and I say, look, this is horrible, I can do better. I have learned to do better. And that's really good. You don't focus on that. So all of these changes, all of this evolution makes you feel, that way about the old code you have. The other thing that really doesn't help this process is complexity. Complexity really kills comprehension. The more complex something is, the harder it is for someone else to understand it, right? We just saw here from the TLDR, like documentation is a big part of that. If you can't understand what's happening, how else are you going to work with that code unless you start, taking it apart and replacing it and rewriting it? Sometimes we just fall prey to bad design. We started off with a wrong idea. The client changed their mind. I mean, clients never change their mind, right? That never happens. We have to deal with these things. How do we deal with this constant barrage of baggage? And then finally we have NIH. Does anyone know what NIH is? Scream it out. Not invented here. The German art of saying no to everything else they have. And that's the idea. You're looking as like, well, someone else did this. I can do it better. Why should I use someone else's code? Why should I use something someone else did? Because I can do it better. This was not invented by us. Let's go do something else. If you've seen any talks here, and at least 3 talks yesterday already mentioned this, open source is the core of our industry. If you're not doing open source, you're burning through money. That's it. We're supposed to be building on the shoulders of giants, right? So the other thing that you really see is change. Like if you look at all of these things that affect and make you not like your old code, it's all about change. We have we have to deal with change constantly, whether it's the market we're in, whether it's the product you're building, whether it's the language you're using, things change constantly. That is the one constant I can guarantee you will find wherever you go in your career as a software developer. Change, change, change. So can we solve this problem, this anxiety of our old code and dealing with change? How can we do that? Now, I wish I could stand here and take on a preacher's voice and tell you I have found the solution to all of this. The reality is there is no solution. There is no silver bullet. If anyone sells you a silver bullet, doubt it. Because there is no one way. If there was one way to fix all of our problems, this would be a really short conference. But no, we have what, 5, 6 tracks? How many speakers do we have around? That's because there's so many different ways that we can solve problems. But going back to that one constant is change. So how do you deal with that constant of change? You need to prepare your code to be replaced. That is the reality. Code will be replaced constantly. Now, this can be a simple process. If you look at the TDD cycle, refactoring is part of the process. It's quick. It doesn't have an impact on the overall delivery, right? Or it can be a really painful process where, for every feature you want to implement, you need twice the time to prepare the code to receive that feature. That's not good. That's going to slow you down. You don't want that. So you need to make sure your code is easy to replace. That's the only way you can deal with all these problems. Making yourself adaptable to change. So what does that mean? Well, it can mean all the way from making the code easy to understand, readability, making sure whoever works with it next understands why it's there, how to work with it. Making it more flexible, again, dealing with change. If you can easily make a change to the code, you're probably going to do it and you're going to have no problems. If you can't easily make a change to the code, you're probably going to struggle, you're going to complain, and that's not going to go well either for you or for the people who work with you. More than that, make sure the code is tested. Testing is the basis of confidence. Make it easy to change, replace, refactor, right? That's our TDD cycle, refactoring constantly. Green, red, refactor. And finally, and if I can give you one silver bullet, and that one you can trust, is the only way to make sure that you're never going to have problems with that code is to make it not exist. That's it. That's the only real way of not having problems with your code. And it is achievable. It's simple. Start using someone else's code, right? So allow me to give you a couple of examples of ideas that you might want to pursue that might help you in this line of making code more flexible. And I'll give you a couple of general ideas and focus on one specific one. So first of all, testing, right? Testing is key to all this. Please, if you saw Larry's talk yesterday, automated testing has been around since 1975. What is your excuse for not doing automated testing yet, right? And that's it. If you're doing refactoring, if you're constantly changing your code and you don't have tests, it's like playing Jenga. Now, Jenga is fun when you have a beer in your hand at the end of the conference, not so much when you're doing it every day at the office. So you want to avoid that. Following simple ideas, simple concepts like solid and stupid. Simple things, single responsibility, open and close principle, list of. I'm not going to go into details, but we all know this. We've heard this. This is in all the talks we go around. So look into these. What do they mean to do? What do they mean to you? What do they mean to your code? Try and absorb those concepts. Modular architectures. We've seen the rise or the re-rise of all of these different concepts, CQRS, event sourcing, all of these architectures that promote hexangular architectures. We've had at least 2 talks already in this conference. They're all there to give you that flexibility. Strict programming. I come from PHP, so I come from a land where strict programming is not the default. Strong typing is not the default. But now we have that option. I mean, most of you working with Java, Ruby, you have that option. And strict programming, while it sounds like that nagging thing that your friend coder always tells you to do, it actually does make a big difference. It allows you to tell the code what to expect. It allows you to avoid a lot of the pitfalls that we have to deal with on a day-to-day basis. Oh, is this really a string, right? I mean, we're very, we need to question our code at every turn. When you start working with more strict programming, type hints and final classes, you start controlling the life cycle of that code a lot better. You start being able to communicate with the code what you expect to happen in the future. So, hey, I don't expect you to extend this class. I expect you to use this public interface. Please send me a string, not something that looks like one. So that really helps you communicate and kill that complexity we were talking about, right? You're reducing the complexity of your code, increasing your comprehension. Pi. I mean, who doesn't love pi, right? It's the opposite of NIH, proudly invented here, right? It's proudly invented elsewhere. Here I go, I'm contradicting myself now. But that's the idea, right? Instead of, having to build everything yourself, open source. Come on, everything has a good package manager nowadays. PHP has Composer, Ruby has Bundler, Python has something weird, I forgot the name. We all have pip, there you go. We all have great package managers. We all have a way of using code that is out there, battle tested, worked on by millions of people. Why not draw from that source? Why? Why not just keep doing that? I mean, it really helps you move along and not have to deal with, having to write every single piece of code. Maybe don't go so far as left pad, but you get the idea. The other thing is readability. Right? If we look at writing code, it is not very different from writing text. And I guarantee when you write a text to someone, except if it's on like WhatsApp or Telegram, you worry about punctuation. You worry about paragraphs. Right? If you're writing a book, if you're writing a report, I guarantee you take care of how you format that text because that is going to change how people are going to understand what you're saying. Same thing goes for code. You can separate logic blocks with white space. Yes, white space. White space is good, turns out. There's many different ways that you can use code styles and then different structures to be able to communicate easier through that code. So readability in code is also a thing. Look into that. Figure out what you find readable and start understanding especially how the brain works. Right? Because at the end of the day, a coder going through a piece of code is exactly the same thing as the machine with a parser going through it. The only thing is we only have one core and it doesn't have that much memory. Right? So you kind of want to be a little bit easier on the brain. So in trying to figure this out and then trying to see how to not regret everything I keep doing. I stumbled into something really incredible to me that at least changed how I work with things. And it's called object calisthenics. It was part of an essay written by Jeff Bay for the ThoughtWorks ontology. Has anyone ever heard of it? No. Wow. Cool. Prepare to be blown away then, I hope. So the idea is, so Jeff wrote this for the ThoughtWorks ontology, and the word calisthenics means exercises, right? So it's small, repetitious exercises that you do over and over to achieve a bigger goal. It's like going to the gym and lifting weights. You're constantly exercising that muscle to then have a bigger goal at the end. And it's the same idea here. These are 9 exercises, and care for the word exercises, not rules. This is not something that you should follow strictly. This is not something that you should not violate. These are exercises. And by repeating these exercises over and over, thinking of things slightly different, it has an impact on your overall thinking. Now, this is focused on object-oriented. It was originally written for Java. We successfully ported it into PHP and started using it and saw really good improvements. Over the years with PHP 7 and all the advances we've had in there, we've actually been able to go closer back to the origin of the calisthenics and follow the same rules. That's how far PHP has come, which is really cool. So keep in mind, these are exercises. Do them in a side project, do them for work. I don't care, just find a place and just try them out for a bit. So I'm going to go over some of these. I won't go into too much detail, but you can always talk to me afterwards if you want. I have a longer version of this that we can talk about. So the first rule is only use 1 level of indentation per method. I was like, what? What does that have to do with quality software? Well, it turns out that with 1 level of indentation only in your method, you have a limit of how much you can do. Remember when you try to put a for each inside a for each? Yeah, that's already 2 levels of indentation, so you can't do that, right? So it may sound silly, but if you keep trying to write software and you keep trying to follow this rule, you will notice that you will extract methods way more often than you would before. You start separating, making sure that that method is doing one thing. Remember the S from solid? Single responsibility, making sure that method does one thing and does one thing very well. And I mean, just try it. Pick up an open source code or something that you maintain and just go through your methods and try to make sure they only have 1 level of indentation. Compare the results, and then you tell me if it's more readable or not. Rule number 2, and please don't throw anything yet, don't use the word else. Now, I have nothing against the word else. That's not the problem. But we all know that forks in decision in code increase the cyclomatic complexity of code. It also increases the amount of brain power you need to understand what's going on with that code. So if you flip your else's, let's say you have an if-else. So if something is bigger than 6, do this, else do that. The thing that you're probably looking for in most of these methods is your method does one thing. So if you have a method called createPost, and you have an if-else that checks if the post is valid or not, you're interested about creating the post. That's what the method does. So if you start flipping your else's, removing them and replacing them with ifs, contrary ifs, what you end up with is instead of having this tree of decisions, you have a nice exit strategy. So all those ifs become breakpoints, the things that will stop this method from doing what it should be doing. So if I say, if this post is invalid, throw an exception. That interrupts the method. If this post is already existing in the database, return early. If I take away all these ifs, so I take out all of the ifs in the beginning of the code, I will see exactly what that method was supposed to do. Oh, this is how you create a post. And these are the breakpoints that stop me from doing that. Now, some people are not big fans of early returns. That's fine. Exceptions are still also a good solution for this. And I find that if you come into a code and you're able to look at this and browse through this backbone of the method and see, okay, this is what's going to stop me and this is what I'm supposed to do, it's a lot easier to understand that. So getting rid of else's does help a little bit with that. Number 3, wrapping primitive types. And actually, you can even disregard the behavior, just wrap the primitive types, especially if you're doing something like Java, where that doesn't have any implications in terms of memory or anything. And the thing is, this really helps you communicate. So for example, if you take code like this, repaint false. Like if you're looking at this call, you have no idea what false means. Should I repaint but not repaint? What does it mean? You have to go back to the origin of that method to understand what is being said. Now, if I replace this with an object, wrapping that false, now you understand, oh, okay, I'm trying to repaint, but not animate while I'm doing it. Right? So it's a simple thing, but you can start, it can be the beginning of something bigger, because now as you start looking at the original method, it was repainting and animating, which is again violating the single responsibility. Now you can start putting all of the behavior regarding animation into that one method, into that object, the animate object. So you can start segmenting data more and more. And there's numerous examples of this out there. If you look at libraries like money libraries, like money handling libraries, they do all of that transforming of data in the backend so you don't have to worry about it, and you have a simple interface to talk to. So you're wrapping what is a float in an object. So try that. Only one error per line. Replace this with dot if you're a Java developer. But essentially it's, Demeter's law, right? You don't want to be looking into the result of the result of the result of the result, because somewhere in the middle there, something might be null and everything blows up, and it doesn't go well. Right? So this is the idea of only interacting with your direct neighbors, not going deeper into understanding, because now if there's a change in that second call you're making, how many places are you going to have to go back to and change how you're dealing with that? Number 5, do not abbreviate. Now, we feel really smart when we abbreviate stuff. I know you do. I know you do. I do too, right? But then you wake up the next morning and maybe you don't feel so smart. I mean, if you look at this code, I'm pretty sure it meant something to whoever wrote it. But right now, they can't even explain to me what it is. I mean, what is that? S-Y-N-Y, New York? What is it, right? But hey, I guarantee you, the first time you write this, I feel good, look at that. I expressed all of that complexity in 2 letters, and I can never understand what it means again. So abbreviation is a relic from the past. Back when we used to code on Notepad and had to write all these variables down. I mean, your IDEs, whatever you use, they're probably going to give you type hinting on the variables. Are you really gaining anything by making a variable that's 2 letters as opposed to 15? Are you? Probably not. Number 6, keep your classes small. Now, what we mean by small varies a little bit from language to language, but in general, every class should have about 10 methods. Every method should have about 10 lines, which means every class has about 100 lines. That's small. It's focused. Again, you're going to have a lot of classes, but you will have classes that are very easy to test, they're very easy to mock, very easy to replace, and very easy to refactor. And that's the goal you're trying to keep up at the end. Number 7, limiting your instance variables to 2. So an instance variable is when you pass an object to an object and it gets saved into a property. So when you create your controllers and you inject all these things into the controller, for example, only inject 2 things. Now the idea here is the more things you inject into the class, first of all, testing is going to become a pain, because you're probably going to want to mock all of these things, and then you're going to start mocking everything, and then you have 15 mocks to be able to run one little method. That's not fun. That's not how testing is supposed to go. So the less things you're injecting there, easier it's going to be to test. Also, it gets you thinking. And that's the rule, that's the idea behind all of these ideas, right? Is to get you thinking a little bit more. Are all these things necessary for the critical path of my method? Can I delay it? Can I use an event-based system to trigger these actions elsewhere? Do I actually need this one class to call everything? Do I need the God class to be talking to everything? So think about that. Using first-class collections, and this really helps you just handle data. Instead of being worried about, oh, this is a collection of apples or a collection of oranges, you can have a collection that has both. You get all of the benefits of collections, of filtering and whatnot, and if you have good object-oriented design behind that, it's easy enough to pull out, okay, I just need the oranges, I just need the apples. Do this with the apple, do that with the orange. So you put that outside of your thing. And finally, don't use getters and setters. Okay, no one threw anything, that's good. And it's like, wow, well, why are we complaining about getters and setters now, right? It's like tabs and spaces. Why are we doing this? But the idea is it's not don't use them and they're evil. It's more about what can you do that's not just a getter and setter. Because if you go look at a getter and a setter, they're very generic. What do they mean? Oh, it means get and it means set. Can I do better? Well, maybe you can. Maybe instead of using a getter and setter, you can have more of a domain-driven approach to it. So for example, if you're coding a game, and in that game you collect a coin, instead of having the coin say, set your score to 1, maybe, let the score actually control that and say, here, I collected a coin. What does it mean to the score? Oh, it means I should add 1, right? Or you can have more, you can deal a lot more immutability, making sure your objects are consistent as they go along. But essentially, you're communicating better what the interface of that object is, what you can do with it, right? So, I urge you, try this. Try it for a month. Just pick up a side project, pick up something small at the office, doesn't matter, open source, or maybe just take some of your code and refactor it, trying to follow these exercises. But just give it a go. Just try it as an exercise. It's not, end of the world. Please don't put this into your PHP Storm inspection checkers. Don't do this as a coding style. Some people have. It's insane. Don't have arguments. Why did you have more than one level of indentation? Sometimes you need it. Sometimes you need to break all of these rules. Sometimes you need to do them all at once. That's fine. But just by trying this and forcing yourself to think every time you make one of these choices, you will notice that you'll start thinking more about the big picture of the code. Now, I started doing this 8 years ago, and I have not written an L since then. That's a lie, I probably wrote a couple of them. But it did change how I think. It did change how I look at the big picture, right? Having smaller, simpler parts of code makes it so much easier to deal with that code. So, here you are at ConFoo. So much to learn, so many new topics. And I will repeat what you said already earlier. Just make sure you take all of this information, go back home, and figure out what it means to you, right? Everyone who's on stage here is showing you a path. It's not the path, it's a path. It may work for me, it may work for someone else, it may not work for you. But that's why you're here. Get inspired. Look at everything you're learning. Internalize it and find what works for you. Thank you very much.